Hello everyone, welcome to today's video. Today's video is going to be on the topic mole concept. Mole concept. It is going to be a very important topic in your higher classes as well. So let us begin the video today. Understand the concept properly. Mole concept. First thing you need to know is Avogadro's law. Pronunciation, whatever you do. Okay. But the spelling should be Avogadro. Avogadro. Okay. You pronounce it as Avogadro, whatever you pronounce it as. Clear? But the spelling should be Avogadro. Okay. Avogadro. Avogadro's hypothesis, or you can write it as Avogadro's law. Okay. You can write this or this, either of this. It was a hypothesis, but it has now stood to the test of time, and so it has been accepted as a law. So we can write it as Avogadro's law or Avogadro's hypothesis. Preferably you should write law because it's no more an hypothesis. Okay. What did this guy state? This guy stated that under conditions, very important, okay, under conditions of similar, I am underlining the word similar temperature. Okay, I am writing in short form, you will be writing in proper expanded form. This stands for temperature, pressure, equal volume of all gases. This is volume, contain the same number of molecules. This is Avogadro hypothesis. What did this person state was that under conditions of similar temperature and pressure, equal volume of whatsoever gas you take, if the volume remains same, number of molecules will have to remain same. Clear? This was proposed by Avogadro and this was taken as a law because it is now proved. So this was proposed by Avogadro. Before this, another person proposed something that we are not going to learn now. It is in class 11. That's Berzelius hypothesis. Okay, Berzelius hypothesis. Here it will be Berzelius. What change? Only this change will change. Berzelius hypothesis stated that under conditions of similar temperature, pressure, equal volume of all gases contain the same number of atoms. But it was later on rejected because it cannot happen. You will understand why it not happens when we will start the chapter SBCOC, not now. Okay. Okay. So this is Avogadro's hypothesis. Hopefully you have understood the thing. Now let us apply this. How will you apply? Okay. You have to remember the statement. Okay. Next, with the help of this Avogadro's law, we come to see the atomicity of gases. Using this, we can say the molecular formula of the gas using this. Clear? We can say the atomicity of this gas. We can say the molecular formula of this gas. Not the gas, any gas. Clear? So two things we can do using this particular thing. Clear? Let us understand. Suppose, first let us find out atomicity. Atomicity. How will you find out atomicity? Using Avogadro's law. Very simple example, let's take H2, this is a gas, plus Cl2, this is also a gas, gives you HCl, that is also a gas. By using Gay-Lussac's law, you get is one volume will combine to give you two volume. Okay, Gay-Lussac's law is explained by Avogadro's law. Okay, so Avogadro's law will explain Gay-Lussac's law. Clear? So instead of this, we can write n number of molecules, to n number of molecules. Understood? N number of molecules will combine to form 2n number of molecules. Clear? Can we write this? Anything wrong is there? No. Nothing wrong is there. Fine. Now, n number of molecules will be formed. N number of molecules will be formed? No. 2n number of molecules are being formed. Correct? 2n number of molecules are being formed. Okay. Achha. Now instead of this one, if I write 1, what will happen? N cuts off, so 1, 1, 2 remains. So we can write instead of this 1 molecule plus 1 molecule gives you 2 molecule. Say, correct or not? Here I have divided by n, divided by n, divided by n. This is all cut off. This is the number of molecule. So that is remaining is what? 1 molecule. So 1 molecule, 1 molecule, 2 molecule. Clear? Okay. Now 1 molecule, 1 molecule, 2 molecule. If you tend to make this as 1 molecule, this as 1 molecule, then what will happen? This will become half molecule. This will become half molecule. And this will become 1 molecule. Now understand the thing. So to make 1 molecule, we are having half a molecule, half a molecule. To make this, we are having half a molecule, half a molecule. Now, if a molecule contains only 1 atom, then half a molecule should not contain any atom. If there is no atom, then what is combining? Nothing. So minimum there has to be 2 atoms in a molecule, because if there is 1 atom, it will be dividing somehow, and that will be no longer considered as a unit of reaction. Dalton's theory states that atoms are the units of chemical reaction. If here we consider that 1 molecule has 1 atom, then atom will be divided. That is no more valid. So we will not consider 1 atom to be in the molecule. So at least there has to be 2 atoms in the molecule. So there are 2 atoms. Next step we can write 1 atom plus 1 atom forms 1 molecule. Clear? So what can we say about the atomicity of hydrogen? Hydrogen has 2 atoms. Atomicity is what? Number of atoms present in 1 molecule. So what is the atomicity of hydrogen? 2. What is the atomicity of chlorine? 2. Written. Clear? Understood? This is how we are going to determine the atomicity using Avogadro's law. Okay? Understood? Clear? Now, from this same thing, you can also get is chemical formula, that is molecular formula. From this same thing I am telling you how to get. Here I am rubbing this because I need to mention something about that. Okay. Okay. After this comes this 1 atom plus 1 atom gives you 1 molecule. This is chemical formula. Okay. Gives you 1 molecule. So 1 atom will give you 1 molecule, right? 1 atom will give you 1 molecule. So what will be the formula? H1Cl1. We do not write H1Cl1, so we write HCl. Clear? Understood? Understood? So 1 molecule of this person, HCl, is made up of what? 1 atom of hydrogen and 1 atom of chlorine. So what will be the formula? HCl. Clear? That also we have derived from here only. So Avogadro's law will give you atomicity and it will also give you the chemical formula. Clear? Understood? Understood? Okay. Next, let us do some questions. Not very big questions, because the big questions have not yet arrived. Big questions have not yet arrived. Don't need to worry, relax. Big questions are not yet arrived. Okay. Suppose we have is a container. Okay, this is a container. Inside this container, we have got is the stake is 1 liter H2. We have got is 1 liter N2. We have got is 1 liter CO2, and we have got is 1 liter H2S. Okay. Assuming no reaction is occurring, assuming that, okay, which one will have greater number of molecules? Which one will have greater number of molecules? This type of questions might come in the exam. Pause the video, try to answer the question. Pause the video and try to answer the question. We have is 1 liter H2, 1 liter N2, 1 liter CO2, 1 liter H2S, which one will have greater number of molecules? Which one will have? Try to answer this question. Pause the video and do it. Okay, now let's see the answer. What does Avogadro's law state? Under equal condition, not equal, actually similar. Under similar condition of temperature and pressure, equal volume of all gases will contain same number of molecules. Is the volume equal? Yes. So who will have the greater number of molecule? No one. Everyone will have the same number of molecule. So answer will be no one. Everyone will be same molecules. This one will have some number of molecule. This one also, suppose let us take, this will have X number. This will also have X number, X number, X number. According to Avogadro hypothesis, under similar condition of temperature and pressure, all volumes of equal volumes of all gases will have the same number of molecules. Clear? Since all are there in the same container, they will be subjected to the same pressure and temperature. So pressure and temperature remain same for all. So the number of molecules will also remain same for all. Clear? Understood the question and the answer? Okay. Next, let us do another question. Okay, you have a container. Okay, temperature, pressure is similar, understand. Inside this you have is 5 liter CO2 and inside this you have is 4 liter of O2 and inside this you have is 3 liter of H2. Okay, now the question remains same. Which one will have greater number of molecules? Will have greater number of molecules. Greater number of. This question requires a little bit of common sense. Okay, pause the video, try to sing the answer and then give the answer. Question is not difficult. Okay, so let's see the answer now. Okay, which one will have greater number of molecules? Whose volume is maximum will have the greater number of molecules. Whose volume? This one. So answer is 5 liter of CO2. Clear? Answer is 5 liter CO2. Why and how? Now, temperature, pressure is remaining constant. Temperature, pressure is same for all. So that will not be considered. Volume. Right? Volume is actually, the space inside it. I can say it as a space inside it. Right? In maths you have done volume of a cylinder, cone. What's that? The space inside it. Right? I can say that the volume of a sphere is the space occupied by the air inside it. Okay? Right? If this is an open sphere, let us say it's a hollow sphere. So air will enter in it. So whatever volume the air is occupying, that volume is also the volume of the sphere. Right? So here also, whatever is the volume of this container is occupied by these three things. So the volume of the container is adding up this three things, that we are not least bothered with. Now see, the volume is increasing. So here the CO2 molecule has the largest number of largest volume, large what to say, area type of. Okay, it's not actually area, but I'm just saying. Okay, so it will have the large number of molecules. It's as simple as that. Here 4 liter O2, 3 liter H2 is there. Okay, and but 5 liter CO2 is there. So who will have maximum? Here, because temperature, pressure is constant. Now you increase the volume, number of molecule will also increase because more number of atoms have been dragged in. In 5 liter, if you calculate the weight, then you will find more weight. Clear? Later on weight is there. To calculate weight, you will get is more weight. So more weight means density will be more, volume will be less. Clear? So that is now changing again. Density equal to mass by volume. Okay, clear? I am not going into physics now. So the thing is that if you increase the volume, your number of molecules is also going to increase. Clear? You increase the volume, your number of molecules is also going to increase. Here 5 liter CO2 is there. CO2 is having 44 gram as the weight. Molar mass is 44 gram. Okay. So from there you can calculate its density, but we do not need to calculate the density rather. Okay, but that is not a problem. Problem is that here when you increase the volume, your number of molecule increase. As simple as that. No need to write any physics. Mass equal to density, mass equal to density into volume. No need to write. What will you do by writing that? Not needed. Okay, mass equal to density into volume. Will add up now into multiply this. Not needed. It's useless. Okay. Clear? So you need not do that. Neither you have to write density equal to mass by volume, nor you have to write mass equal to density to volume. Nothing you need to write. Just you need to mention that the number of molecules increases with the increase in volume, because condition of temperature and pressure is similar. Clear? Understood? So this type of small question of 1-2 marks you will get it. Okay. Now let us move on to the next part. That is relative atomic mass, relative weight, molar mass, molar volume, completely going into the mole concept. Then we have the big numericals. So the thing is, first is relative molecular weight. Now I have got nothing new to say about relative molecular weight. You already learned relative molecular weight. Weight in class 9 you did, class 8 probably you did, I don't remember. Class 9 you have done. What is relative molecular weight? You have done CaCO3 you used to break down into 40 plus, then this is 12 plus 48, like this you add up and get some answer. Correct? You add it and get some answer. 100 gram, 100, it's 100 U or AMU, but here we are going to consider molar mass. 100 gram will be done. So what we are doing, you are adding the sum. You are adding the sum of the constituent elements. So that's the relative atomic mass. Clear? That's the relative atomic mass that you have done. Okay. Clear? So this is relative molecular mass of the compound. Molecular mass. Relative atomic mass is, this is relative atomic mass of calcium, relative atomic mass of carbon, relative atomic mass of oxygen is 16, 3 times, so it's 48. Clear? So relative atomic mass. How will you define relative atomic mass? So relative atomic mass means that how much number of times is the atom of one element heavier than 1/12th times of the mass of atom of carbon 12. It is defined as the number of times one atom of an element is heavier than 1/12 of the mass of carbon 12 atom. Clear? So relative atomic mass is basically mass of one atom divided by 1/12 of mass of C12 carbon atom. Okay, so this means that 40 times it is heavier than 1/12 the mass of C12 atom. This means it is 12 times heavier than 1/12 of the C12 atom. Okay, it's carbon only. Okay, and this is 48. Okay, 16 actually, so it means 16 times heavier than that. Understood? Clear? So relative atomic mass means that how much time one atom of an element is heavier. Clear? Understood? Okay, next, fractional atomic mass. Fractional atomic mass is coming into play when there are isomers. Okay, sorry, not isomers, isotopes. No, isomers are in organic. Isotopes. Okay, like 35.5 Cl is there that we use, another is there 39.5 Cl. Two types of Cls are there, 35.5 and 39.5 generally. Clear? But when we write, we do not consider these two. What we consider is 35 and 37 Cl. Okay, this one. So you will do it accordingly. Okay, 35 Cl and 37 Cl. Okay, so what we do is we do the average 35 plus 37 upon 2. You get it somewhat 2 and 36 is 72. Okay. Clear? Only doing this much will not help you. What will you get answer as 36? That is approximately relating to 35.5. Fine, it's fine. But 35 into 3 plus 37 into 1. This will be multiplied by 3. Now you will say why? That's reason you will get in class 11. That is constant composition. Okay, they are found in a constant composition of ratio 3:1. That is why we are multiplying it by 3 and this by 1. 1 is same, that is why we are not writing it. Clear? So the answer will be this, not this. It's basically approximation of this, but it's fine. Okay, this level is fine. Clear? So we take 35.5 as the atomic mass of chlorine, not 36, not 34. Clear? Not 35. Understood? Reason is very much clear over here. Okay. Now relative molecular mass, I need not say anything because they have already done relative molecular mass. Next, gram atom. This term you will often get in mole concept, gram atom or 1 gram molecule. What does this exactly mean? Suppose you are given with 1 gram atom of oxygen. Answer is 32 gram. Suppose you are given with 1 gram atom of carbon dioxide. Answer is 44 gram. Where am I getting the answer from? Answer is multiply this. What is the total sum? 32. That is the answer. So 1 gram atom means the quantity of the element that will weight equal to the atomic mass. Clear? Quantity of the element that will be equating equal to its atomic mass is the gram atom. Understood? Clear? This is dioxygen, so 32 gram. Monooxygen, it's 16 gram. Clear? I have written O2. CO2, it's 44 gram. So 1 gram atom of CO2. No, it's gram molecule of CO2. Right? 1 gram molecule of CO2 is 44 gram. Understood? Okay? Okay. This is gram atom. Next is molar mass. Now you have been doing molecular mass. Molar mass is nothing different. It's basically everything you will express in gram. Clear? So the molecular mass expressed in gram is called gram molecular mass or molar mass. Nothing different. Okay. In the molecular mass, that's relative molecular mass, we are determining in A mu U. Here we will be determining only in gram. Grams will only work. Is it understood? Clear? Now we are moving on to the very important thing. So please look here clearly. Okay, complete focus, because it is a very important thing. Mole. What does this word mean? Mole indicates amount of substance. Fine, I know that. What exactly is mole? How will you define mole? Mole is basically how many chemical units are there. Now I am not specifying which chemical units are there, because it can be anything. It can be an ion, electron, proton, whatever. Depends. Generally we can take it as atom, molecular, ion. So we cannot specify it. What is it? Clear? So what is a mole? What is a mole? Mole is how much is the amount of pure substance. How much pure substance will have the same number of chemical units. Pure substance. It cannot be an impure substance. You already know that. We are dealing with pure substance. So pure substance. Same number of chemical units as their same number of chemical units as they are in 12 gram of C12. In this much, how many atoms are there? That will be equating to the chemical units. This is defined as mole. Confused? Right, no problem. Understand. Mole is the amount of pure substance that is having the same number of chemical units. That can be molecule, ion or atom. Same number of chemical units as there are atoms. So chemical units will be equating to the number of atoms present in 12 gram of C12 carbon atom. Clear? So how many atoms are over here? That will be equating to the chemical units in the pure substance. Then we will say it as 1 mole. Understood? So 1 mole is defined as the amount of pure substance that has exactly the same number of chemical units as there are atoms in the 12 gram of C12 carbon atom. This is mole. So is the definition of mole concepts clear? Mole concept definition clear? Not actually concept, it's mole. So mole definition is clear to everyone. Have you understood what is meant by mole? Okay, now moving on to a very important thing. The value of Avogadro number. Value of Avogadro number. Avogadro number is defined, not defined actually, denoted by Na, and its value stand at 6.022 into 10 to the power 23 chemical entities. You cannot specify it as molecules, ions or atoms. It's chemical units. Clear? It will change depending on when or in what sense are you using it. So Na is the Avogadro number. Avogadro number. This is nothing but Avogadro number. Okay. And the value is this much. Depending on when you are using, you can change it to only 6 in class 10 because you do not have the calculators available. So fine, you can take it 6 depending on what the question is. It will be mentioned that whether you will be taking 6.022 or 6 in your 11 paper, not in 10 because not having in 10. Okay, it will be mentioned which value you will be taking. So you will take accordingly. Clear? So this is Avogadro number, value is 6.022 into 10 to the power 23 chemical units. Clear? Definition for Avogadro number generally does not come in exam. Clear? It's defined as the number of atoms present in 12 gram of C12 carbon atom. Very simple definition. Okay. Now, it is seen that equal volume of all gases occupy the same volume at similar condition of temperature and pressure. Clear? It is seen that, sorry, not equal volume, sorry, not that. 1 mole of any gas, what I said, 1 mole of any gas will occupy same volume at similar condition of temperature and pressure. Clear? 1 volume of 1 mole of any gas will occupy the same volume at STP or similar condition of temperature and pressure. What is the volume? The volume is 22.4 liter. That can be written as 22.4 dm cube. All conversions you will do. Okay, 22.4 this cm cube. This here also equates to this much milliliter. So all this is called molar volume. Okay, using this calculation you will be applying unitary method when you will be doing the sums. So this is molar volume. 1 mole of any gas given in the question will be occupying the same volume in STP or similar condition of temperature and pressure. What is the volume? 22.4 liter. Clear? Understood? You have to remember the values because these values will not be provided in the question. Okay. Okay. Let us do now few questions. Okay, let us do few questions. Okay. Let us do this question. Okay, question is, let's write the question and try to solve the question. Let's understand how to get the approach to the question. Okay, it is said, calculate the atomicity of chlorine if 35.5 gram of it occupies 11,200 centimeter cube at STP. Clear? So what is it saying? It is saying that 35.5 gram is occupying 11,200 liter at STP. Alright, fine. Sorry, not liter. Centimeter cube. Alright, fine. Now we know something. We know something that 1 mole will occupy how much? 22,400 centimeter cube. We know this. Now what is the value of 1 mole for chlorine? It is 35 or 71? 71. So 71 grams should occupy 22,400 centimeter cube. Am I right? So 71 gram should occupy 22,400 centimeter cube. Clear? We know 1 mole is occupying 22,400. So how many how much makes 1 mole for chlorine? Dichlorine. It's 71 gram. So 71 gram is occupying 22,400 centimeter cube. That is at STP. Right? So gram molecular mass is 71 gram. How will you get the atomicity? Question asks atomicity. So how will you get the atomicity? Atomicity you can get is molecular mass, whatever is the molar mass, divided by whatever is the atom mass, atomic mass. So what is that? 75 divided by 35.5. Okay, that's 60. That's 70 approximately 2. Clear? So what is the atomic mass? 2. Clear? What is the atomicity? 2. Understood? So this type of questions you will be doing in this chapter. Okay. Okay. Now let's do some more questions. Okay. This type of question when we will be doing, you will be getting the approach to how to use the question. Okay. See this type of question. Let's do one question. Okay, it is asking how many grams of aluminium is present in 0.2 mole of it. Okay, so it is asking how many gram of aluminium is present in 0.2 mole. Okay, 1 mole. First you need to get the value of 1 mole. What is the value of 1 mole for aluminium? 26 or 27? 27. Aluminium has 1 mole 27 gram. Right? 1 mole is 27 gram. So now it is asking how much? 0.2 gram. So 0.2 gram. Gram or mole? Wait. 0.2 mole, not gram. So 0.2 mole. Okay. So what will you write? 0.2 into 27 gram. Correct. So 2 by 10 into 2.7 gram into 27 gram. So that's how much? 54. That is 5.4 gram. Understood or not understood? Understood or not understood? Approach is get 1 mole, apply unitary method. Now if you make up an error over here, then I have got nothing to say. Might happen, errors can, that's fine. But you should be avoiding it, okay? So unitary method simply applied, you have to get this value because this value will not be mentioned in your question. So you need to memorize this value. Clear? So we got the value of 1 mole, then we found the value of 0.2 mole, okay? Clear? Even you can do this calculation in your brain. Brain calculation, mental calculation can also help you. 1 mole is 27 grams. 27 into 54 divided by 10 is 5.4. They did not even write this directly. But you should write it because teacher will not understand a mental calculation. Okay. Okay. Next question. Let us see. It is saying how many grams are present in 0.1 mole of HCl. How many grams of HCl are present in 0.1 mole? Right. HCl is how many? 36.5. HCl is 36.5 gram. So how much will be the weight? 3.65. Okay. HCl is 36.5 gram molecular weight. So this will be 30.65 gram. How did I get it? Directly I did it mental calculation. Now how did I get it? 1 mole of HCl. How much? 36.5 gram. 0.1 mole will be how much? Now multiply 36.5 into 1 by 10. That is 33.65 gram. Clear? Understood? Clear? For time consumption in the MCQs and when you go for competitive exams, that time you cannot sit and go for this. You have to apply your mental calculation. Directly you will get the answer. Clear? Okay, next. Though this sum will not come there also. Difficult sums will come. Okay, next H2 are present in 0.2 mole of it. How many they said? 2 mole. 18 is 1. 18 to 2 is how much? 36. 0.2 will be divided by 10. 3.6. Clear? So answer will be how much? 3.6. Again I am showing. 3.6 is the answer. 3.6 gram. 1 mole is having 18 gram. 0.2 mole will have, multiply 18 into 2 upon 10 gram, that is 36, divided by 10 gram, that is 3.6 gram. Got it? You don't have time to write this all much. If you have long other questions left, mental calculation works. Clear? If you are good at it, then go for it, otherwise don't try. Okay, CO2. CO2 is given 0.1 mole, so it will be 44.4 gram. No, it will be 4.4 gram. Clear? Answer is 4.4 gram. Okay, I am not showing this because this is very easy. 1 mole is 44, 0.1 is divided by 10, 4.4. Understood? Okay, next let us do some questions. Okay. There is a question that says, we just check once. Okay, let's do this question. I just check the answer on the calculator is coming right or wrong. Okay, yes, calculate, let's see the question. Calculate the mass of, first part, 1 atom of oxygen. Very important, it's given as oxygen, okay, not dioxygen, so please be careful. Okay, 1 atom of oxygen, 1 atom of oxygen, dioxide molecule, should have been atom. Okay, so 1 atom of oxygen. How will you calculate it? Direct unitary method will be applying, right? Direct unitary method. Now how will you do it? That is, Na number of will occupy 6, not occupy actually, weight is 16 gram. This is Na, so here it will function as atoms. So Na atoms will occupy, not occupy, why am I saying occupy? Na atoms will be weighting 16 gram. So how much will be 1 atom weighting 16 divided by 6 into 10 to the power 23. For your level, 6 into 10 to the power 6 into 16 will work. Okay, 3 into 8, that is 8 by 3, that is 2.6. 6666 will go, so I am taking 2.67 into 10 to the power minus 23, that I can write it as 26.67 into 10 to the power minus 24. Okay, gram. Clear? Understood? How did you get the answer? You got the answer by taking this as a value of 6. Okay, taking the value of this as 6. Now, if you consider this value to be 20, if you consider this value to be more, that is 6.022, then let me show you what comes as the answer. Okay, here if you can see, I don't know if you can see or not. Here if you see, I have divided 1 divided by A. Okay, A value is Avogadro number. Clear? Now this is 1 divided by A. Now I am equating this. See, the answer is 1.666. So this is correct. So Na is Avogadro number. Now I am dividing 16 divided by Avogadro number. Divided, what is the answer? Answer is 2.656 into 9246 into 1 10 to the power minus 23. So can you see? It will be 26.569, that is 26.57. So where lies the difference? 26.57. Here lies the difference. So in the calculator, when we are dividing it by the Avogadro number, taking as the value as, taking the entire value, then the answer is a little bit different. That is, here it is different. So we will be for now considering 6 because we do not have the calculators available. Moment it will come to us, we can do it directly. Clear? Understood? So we are considering 6 as the value. There is no need of calculator right now. Not difficult, that's sum. Okay, next one is said an atom of hydrogen. An atom of hydrogen. That's more easy. Na is 2 gram. So 1 atom will be twice divided by 6 into 10 to the power 23. That's divided by 3. So 1 by 3 into 10 to the power minus 23 gram. Clear? That's how much? 0.3333 into 10 to the power minus 23 gram. So that if you go for 3.33 into 10 to the power minus 24 gram. Clear? Understood? Sum is not difficult. Sum is not difficult. Understood? Clear? This type of sums are not difficult. Okay. Let's do the next sum. Remember, checking the answer much is different. 3.321. This is 1.333. Okay, did you get the answer? Okay. Next one, let us move on. Acha, before I move on, I want to change the answer over here a little bit. Okay, there was a slight error in that. One atom of hydrogen is Na will occupy 1 molecule. What am I writing? Na will occupy 1 gram, right? I wrote 2 gram, that's the error. And one atom will occupy, it has only one atom. Understood? It is only one atom. So it will be 1 divided by Avogadro number. Its value is fixed, 1.6606 into 10 to the power minus 24 gram. And that's the answer. Clear? Slight changes might occur. Answer is fine. 1.6606 will be the answer. Okay. Upon dividing, you get is 1.6616. Okay, so that 0 might change, that 0 might not change. There will be, if you round it from here, then the 0 might change to 6 also. So that's different, but the answer will be around 1.6606 to the power minus 24. Okay, the previous one that I did is wrong. Okay, do not follow that. Okay, it's 1.6606. Okay, that was for dihydrogen. Did not see that. Okay, next one is a molecule of NH3. A molecule of ammonia. A molecule of ammonia. Acha. Now molecule of ammonia contains 17 gram. Total weight is 17 gram. So Avogadro number will contain 17 gram. So one molecule will weigh how much? 17 upon Avogadro number. That's how much? Roughly 1250. 28, not 20, 2.8 obviously. 2 6 are 12, 50, 0.8, 203 to 10 to the power minus 23. Around this much only will come. Okay, around this much will only come. Might be slight changes are there. I did in mental calculation. Might go wrong. Okay, I am just checking once. Wait. Divide by 6 into 10 to the power 23. Divided by 6. 17 divided by 6. It's 2.83. Okay. And into 10 to the power. It's okay. Okay. So rough changes might occur. Range is accepted. So do not go out of the range. Otherwise there will be a problem. Okay. Now if you divide it by 17 divided by Avogadro number, then your answer will come as 2.8229. that's 2.823 roughly. Okay, so this answer is accepted. Okay, roughly this answer will be accepted. Okay, next one. Yes, 10 to the power 22 atoms of carbon. This question is not a disaster question. Okay, not a dangerous question. 10 to the power 22 atoms of carbon. Okay, now here no weight has been specified, not has been told one atom, one molecule. No, it has been told 10 to the power 22 atoms. So not difficult, right? It is difficult. Na number of atoms occupies how much? 12 gram. So how much will one atom occupy? And this bother with one atom, right? We do not need one atom, so it's Na. How much we need? 10 to the power 22. So one extra step is there, nothing else. This 12 into divide by 6 to the power 10 to the power 23 into 10 to the power 22. Clear? This will be 2. This will be 10 to the power minus 1. 10. So this will be 2 by 10. That is 0.2 gram. Clear? Understood? Okay. So 10 to the power 22 atoms of carbon means how much? 0.2 gram. Alright. So hopefully now many more sums are following on. Now you have to keep on practicing with the sums. Okay. Because this type of questions will be asked. Not now, maybe later on. Okay. Checking if there is any other question or not. Okay, now let's do some volume questions. These are all weight questions we have done. Now let's do some volume questions. Okay, let's do some volume questions now. Okay. Relative molecular mass questions I am not giving because it's very easy to do. We have already done 1000 times. I am not giving the question. Okay. What is the mass of 56 centimeter cube of carbon monoxide at STP? What is the mass of 56 centimeter cube of carbon monoxide at STP? So it has been told 56 cm cube carbon monoxide weighs how much? How will you find out? To need that you need the 1 mole value, right? So 1 mole value means 22,400 centimeter cube has weighted how much? 12 plus 16 how much? 38. No, 28 only. 28. Clear? This is 28. This much is 28. Now from here you will come to here or here you will come to here. Here will come to here because we need this value. So it's 56 centimeter cube will be coming to how much? 28 divided by 22,400 into 56. Okay. Now calculate the value to get the weight. Okay. Please check what is the answer coming to. Complex calculation there again. 28 into 56. Okay. If you do the calculation, you will get the answer as 0.07 gram. Clear? 0.07 gram. You can cut short from here. 56 will go with 4. 4 5 is round. This will go with 4. So 4 there cut left. 4 5s are 20. 5 5 6 0 0. This got to be 28. No, not 20. Definitely. 4 1s are 4. 14. Okay. This is 20 36. This is 200 and 700. Okay. So this is clear? 7 by 100. That is 0.07. So how are you getting? First and foremost thing is what is being asked in the question, what you have to find, what formula you have to apply, that you have to understand from the question. Okay. Okay. Now the last sum that we are going to do today in this video is how to calculate mole. Mole we have dealt with so many things, but you know discuss what is mole. Mole we have discussed, but how to calculate it we have not discussed. So mole if you want to calculate, that is denoted by the small n, is given weight divided by atomic weight or molecular weight. Clear? Atomic weight or molecular weight depends on whether it is an atom or a carbon, element or a compound. Okay, suppose 12 gram of Mg is given to you. Calculate n, that is calculate the number of moles. How will you get it? N equals to 12 upon 24, so it's 0.2. Clear? Whenever it is less, something points. Okay, greater 1 point something, maybe more than 1 point something also. Clear? Whereas we had been this 48, that would have been twice this 12, so it's point. So how will you calculate? Given weight, whatever is the given weight, divide by the atomic weight. Okay, so that's all I had to say from the first part of the mole concept. In the next video, we'll be talking about how to apply this thing in chemical reactions. Okay, last part is chemical reaction will be applied. So let's, in the next video, we'll be seeing how we'll be doing in a chemical reaction. You have all basic reaction, Na plus Cl, Na plus Cl2 forms 2NaCl. How will you apply the change, mass relationship, mass volume and volume. So all that we'll be keeping for the next video. Okay, thank you. Hope you all have enjoyed the video. See you all in the coming video.